Yo, in this video we're going to apply what we learned in the last set of notes about inscribed angles. So we learned that the inscribed angle, which is the angle with its vertex on the circle, like we see with that angle D right there, the vertex on the circle. We know that that inscribed angle is equal to half of its intercepted arc. Okay, so the angle is half of the arc, or we also talked about the converse of that, how the arc can be equal to 2 times that inscribed angle. So we talked about how that's different than a central angle, which was just equal to the arc. With this one, you got to do a little bit of math, okay? You'll have to divide the arc by 2, or if you're trying to find the arc measure, not length, if you're trying to find the arc measure, then you're going to have to double the angle. So let's try it. Let's get a couple of examples going. I got 8 examples here, but they don't take a whole lot of work. In this example, number 1 over here, I've got the inscribed angle D. So I know that angle D is equal to half of its intercepted arc, which is arc EF. So it's equal to half of EF. All right, I'm just writing this one out so you can get the kind of get in the groove of what we're doing here. So angle D is equal to half of the 146 degrees. And half of 146, I think it's like 73. So angle D must be 73 degrees. That's how we do it. It's half of that intercepted arc. So same thing here. All right, I've got my inscribed angle. So it's going to be half of that arc. The arc is 64 degrees, so that means that angle is going to be half of that, 32 degrees. Cool. So angle H is equal to 32 degrees. The measure of angle H is 32 degrees. That's what we're doing. Now in the next example, it's the same thing. So the angle A is going to be half of its intercepted arc. Intercepted arc is 100, so angle A must be 50 degrees. Cool. This one's a little different because they give us the angle. So I know that that arc is going to be 2 times, it's going to be double, right? So it's going to be 2 times 80. It's going to be 160 degrees for arc TS. So the measure of arc TS is 160 degrees. So you see that these problems don't take a whole lot of time. The next couple examples are going to be a little tougher. But you're either finding the arc or you're finding the angle measure using these fun rules up top. Here's a couple more fun examples. All right, in these examples, we got to do a little bit more work. In example number 5, I don't know the angle. I'm looking for it, and I also don't know the arc. So I'm going to use the information that's given to me here to help me find the arc, and then I can find the angle. I know that the whole circle adds up to 360 degrees. All the arcs around that circle should have a sum of 360 degrees. So I know this circle is made up of LJ, LK, and JK. So if LJ and LK are 90 degrees and 130 degrees, then I can subtract those from 360 and figure out what that missing arc is. So 360 minus 90 is 270, and then minus a 130 is 140. I hope that's right. So this arc should be 140 degrees. So if that arc is 140 degrees, I know that the inscribed angle is half of that. So angle L, the measure of angle L should be half of 140, or 70 degrees. Cool. So the same thing, but you gotta find a little bit of information before you get going. All right, with this one, we're looking for this question mark over here. Well, I know this piece is 85, and I know that if this angle is 77, then the arc is going to be double the angle. So 2 times 77, what's that, 154 degrees. So that arc is 154 degrees. So if I wanted to find this arc over here, the remaining arc of the circle, I can start with the full 360 degrees of the circle, and I can subtract the 154 and the 85, and that should give me the leftover. So I'm gonna do that real quick. I got my handy dandy calculator out. So 360 minus 154 minus 85, and I'm left with 121 degrees for that arc EC. All right, so we're still applying what we know about circles. Over here, oh, I see something fun. I see a diameter. And if that's a diameter, that means RQ is a semicircle, and a semicircle is 180 degrees. So that chunk is 180 degrees. I have a 33-degree angle, which means the arc is going to be double. So if that angle's 33, then the arc is 66. All right, so to find that missing chunk over here, the remaining chunk from the circle, I'm gonna again subtract from 360 degrees, because that's a full circle. Minus 180, minus 66, and that leaves me with 114 degrees. So arc QS has a measure of 114 degrees. All right, and my last example, that's not a diameter, so I can't use the same trick, but I know that since that angle is 40 degrees, that inscribed angle is 40 degrees, that arc is going to be double, so it's going to be an 80. So that's 80. This is 130. So the remaining chunk can be found by subtracting from 360, the total of a circle. So 360 minus 130. Ooh, I can do that without a calculator. That's 230. Oops. Oh no. It's my first day. And then minus 80. Oh no, what's that going to be? That's going to be 150. So that should be 150 degrees. You might want to check my work because I just found out that I can't subtract. All right, guys. So you saw some that were super easy. You just had to double or half depending on whether you're trying to find the arc or the angle. And then you saw some that were more fun. You had to use the fact that the whole circle added up to 360 degrees. So I hope that helps you with your work. Have a wonderful day. See ya!